Hello everyone. I just want to give some examples on operations with Cartesian vectors. We have two vectors u and v. They're given in Cartesian form or algebraic form, and they are asking us to add these two vectors up. So we're going to add vector u with vector v by writing each vector in algebraic form, and we're going to add component by component. So the x components we're going to add together and y components together. So 9 and 24, that would be 33. If you add 9 with 24, that would be 33. And if you add 10 with -4, that would be 6. So this is actually the vector sum of vectors u and v. In order to subtract them, we do the same thing, but this time we subtract the corresponding components. So 9 minus 24, that will be negative 15, I believe, right? Negative 15, right? Because 15 plus 9 is 24. So negative 15, 9 minus 24. And then negative 4 minus 10 would be negative 14. So that would be the difference vector, u minus v. Then it says 3 times vector u plus 2 times vector v. So we have a scalar 3 that has to be multiplied by vector u, and we said that we have to multiply by every component, and 2 times vector v, 24, 10. So this would be 3 times 9, 27. 3 times -4 is -12. And then 2 times 24 is 48. 2 times 10 is 20. So if you add them up, 27 and 48, that's 60, 75. And -12 plus 20 would be 8. So this is the outcome of 3 times vector u plus 2 times vector v. Okay? Magnitude of vector v we are asked to find. So we know that the magnitude of every vector can be found by the formula that was derived from Pythagorean theorem. So this would be something like v1 squared plus v2 squared in this case, under the radical sign. So 24 squared plus 10 squared, that would be, that would be 24 squared plus 10 squared. That would be 512. 512, so that's 1024. So 26, I think the answer should be, but let's see, why are we torturing ourselves? 24 squared plus 100, and you take the square root, of course, 26. All right, so the brush fell down. So that is 26, as I said. Okay, so that is the magnitude of vector v. Then it says u hat, which is the unit vector along the direction vector u. So we said that we have to divide it by its magnitude. So the vector 9, -4 has to be divided by its magnitude, which is found by 9 squared plus -4 squared. So working this out, 9 times 9, 81. 4 times 4, 16. So 80, 90, 97. So square root of 97. And we can say this is 9 over square root of 97, comma, -4 over square root of 97. So this would be the unit vector in the direction of vector u. And if you square this component, if you square that component, add them up, take the square root, that would be equal to 1 for sure. So we can check that 9 squared is like 81, and 84 squared is 16. 81 plus 16 is going to be 97. The denominator squared will be just 97 because the radical will be gone. So 97 over 97 is 1, square root of 1 is 1. So you see that this vector indeed is a unit vector and its magnitude is equal to 1. and furthermore, it is in the direction of vector u that is given. Therefore, it's called the unit vector along direction of vector u. It's denoted by u hat symbol. So this next one, it says vector v can be written in terms of its horizontal vertical components in this form: magnitude of v times cos theta and magnitude of v times sine theta. And they're saying find measure of angle theta itself. So this is not a secret. If you have 24 and 10, so 24 and 10 is here. There's a point there, point P, and this is vector OP, 24 and 10. So that's vector V basically. Vector V is the same as vector OP. And what they're asking is for this angle theta, because they say that the horizontal component of vector OP is nothing but hypotenuse times the cosine of theta. This comes from SOHCAHTOA. This comes from the fact that cos of theta in any right angle triangle is the ratio of adjacent over hypotenuse. So these are not like secrets. So we consider this is actually magnitude of V times cos theta, and this part is magnitude of V times sine of theta, because sine is the ratio of opposite over hypotenuse. So if you multiply the hypotenuse by the sine of the angle theta, then it makes with the x-axis, that will be the opposite side, and that is nothing but the vertical component of vector OP, of course. So that's where this formula is coming from. To find measure of angle theta, well, we can say, what can we say? We have all the information here. We can say tangent of theta is the ratio of opposite over adjacent. So that's 10 over 24. Therefore, if you take the inverse tan of 5 over 12, then that will be the measure of the angle, basically. So we grab the calculator and punch in inverse tan of 5 over 12. And sure enough, it's 22.6 degrees. 22.6 degrees. So that means that the angle theta, that vector OP, or this so-called vector V, 24, 10, makes with the x-axis is nothing but 22.6 degrees. Okay? Now we can find the components if we want. We can say this is actually magnitude of V, which was 26 times cosine of 22.6 and 26 times sine of 22.6. And I bet this has to be equal to 24, 10 for sure. And just for the sake of it, I'm going to punch in cosine of this angle I got. And I'm going to multiply it by 26. And sure enough, I get 24 here. So we see that this is not magic. It is working. Another exercise, we have 2 points A and B. Coordinates are 8, 9. So 8 and 9 will be here. And 16, 3. So 16 and 3 is here. So a vector like this. Okay, that's vector OB. And it says find this vector. Okay, so generally speaking, we have 2 points, and the coordinates in general could be x1, y1, x2, y2. Okay, or it could be x sub a, y sub a, and x of b, y of b. Okay, generally speaking, these are the coordinates of the points, not necessarily 8, 9, 16, and 3. In general, you can write the vector, and when we say vector, we mean the magnitude of the vector, obviously. It can be found by using Pythagorean theorem. So you can always construct a right angle triangle, and you can always use Pythagorean theorem. So different in the x coordinates, you square it, and then you find the difference between the y coordinates, you square it, and then add them up and take the square root. Basically, nothing but Pythagorean theorem. So whatever the run is, okay, and whatever the rise is, you just square the run, square the rise, add them up, take the square root to find the length of the hypotenuse. Okay, so this would be x of a minus x of b squared, And it doesn't matter if you say xb minus xa or xa minus xb, because you're squaring it anyway. So whatever you feel like, you can write it ya minus yb all squared. Okay? Or we can write this formula in terms of x1, y1, x2, y2. Now the numbers here are 8 minus 16. That is the so-called run squared, change in the x values. And 9 minus 3, y of a minus y of b. So 9 minus 3 all squared. So 8 minus, that's the rise squared. So 1 squared plus y squared, basically. So 8 minus 16 is negative 8 squared. That's going to be 64. And 6 times 6 is 36. Okay. Because 9 minus 3 is 6. 6 squared is 36. Add them up. It's going to be 100. And that is 10. We write units because it is 10 units. That's the magnitude of this vector AB. Okay. So again, this formula perhaps is a good one to remember. And that is telling you how to find the magnitude of a vector given the coordinates of the endpoints of that vector. The coordinates of the tail, coordinates of the tip, xa, ya, xb, yb, and that's how you calculate the length of that vector. Okay, thank you very much. I'll give you more examples in future.